Hello, listeners. Welcome to the last episode of our talk on bedforms. In the past, we've talked a lot about ripples, dunes, tiles, and tidal bundles, but in this section, we'll focus on outcrop examples taken from field trips. So this is figure 1. It's an outcrop example of a planar cross-bed. So here we see the upper and the lower bedding planes in the dashed yellow lines, and in between them is what we call the planar cross-beds. So another quick observation is that the top set has been eroded by the upper bedding plane, but we still have some hints of the bottom set preserved in this section. This is an example of trough cross-beds taken from one of our inland basins here in Nigeria. We actually see that these are potentially formed by large-scale, ripples, and they may have formed by the migration of either sinuous or catenary ripples. Figure 3 is showing an example of herringbone cross-beds, again taken from an outcrop visited in one of the field trips. We actually see an example of the geometries and how above and below the blue line you have difference in the deep direction of the faucet planes. So this is one example, and then yet this is yet another example. Alright, so figure 5 is an example of a reactivation surface taken from Omonia in Nigeria. So we have the field nodes actually sitting on the dashed blue line, which is the reactivation surface. So above and below this reactivation surface, we have different sets of faucet planes or cross-beds dipping in the same direction. This is a classical example of the Hummocky and Swaley cross-stratification. Now recall we had mentioned earlier on that these are indicators of shallow marine conditions. So if you take a closer look at figure 1, you see what appears like a bull's eye feature. So you have two curved surfaces, one above curved downwards and the one below curved upwards. The surface above, which is curved downwards in red here, is called a hummock. And the one below, which is concave up, is in blue, is called a swale. Now, this is another example which shows a much larger, version of the Hummocky and Swaley cross stratification. Again, we see similar representation of the hummock, which is the red surface curved downwards, and the swale, which is curved upwards. So I'll be showing you other examples of cross-bedded sandstone units, but with focus on processes or features that can alter or impact reservoir quality. And these include bioturbation, mud drips, extra or intraformational clasts, diagenesis, stress, or strain. This is a bioturbided sandstone unit which shows clay distributed in different forms as drapes and as clay fields or clay balls within the sandstones. So in figure 1, we actually see clay drapes on the faucet planes, and you also observe that some of the burrows have been filled by mud or clay contents. In figure 2, we see an excellent example of ophimopha burrows, across a clay drip faucet plane. Now, these are very important, elements or features because they tell us a lot about our overall reservoir quality. And then they also give us some hints on what we expect in terms of preferred fluid flow direction and also reservoir connectivity. Here we see extraformational clasts and sandstone nodules within a formation. In inset 1, we have a clast material along the faucet planes, while in inset 2, we actually see sandstone nodules within the formation. So here is another example where local original stress actually impacts reservoir quality. Here in figure 1, we're looking at highly indurated sandstones. We note checkerboard pattern, which has been interpreted to be due to stress along different directions in the area. Figure 2 and 3 here shows the faucet plane of the cross-bedded sandstone in areas where the stress has not significantly impacted the rock. So this is the last figure. This is actually an example where impaction pressure can actually lithify sand. So these are large-scale aeolian sand dunes which have been preserved as cross-bedded sandstones somewhere in Utah. So the message here is that rock compaction can significantly reduce our reservoir porosity. All right, so this is all I have on the series. Thank you for your time and thank you for listening. It's been a pleasure having everyone on board. Until next time when we connect again on other topics, this is Ifeanyi Obi.